We're going to set up our axis for our DM45 CNC conversion. If you bought a kit from us and you're going to use UCCNC, we will provide you with a profile and a suggested pinout. In this case, we go into our settings, we look at our x-axis and make sure that our step and direction pins are correct and our ports are correct according to our wire diagram, which they are. Next we check out our home pin for that axis, and the X limit is on pin 11, port 3. Now depending on what type of home pin you have, whether it's just a simple switch, inductive sensor or the PNP or NPN, depends on how you wire it to your controller. If your home switch provides a power output, then you would put that power to the plus pin, so plus 11, and then put minus 11 to earth. If it provides an earth, then you would put your pin to 11 minus and provide a power to the 11 plus. Basically the controller is just sensing when there's a high or a low signal, and then we'll activate the home switch. In this case we've got active low set. We check our home pin for our X. I put a piece of steel on top of our X. So we have a home pin wired up. We want to check to make sure it's active and it's on the right one. So we go to diagnostics. You'll see nothing's activated. We're on port 3, pin 11. It's showing it, it's got a high signal. When we put a piece of metal onto the sensor, it goes low and activates the X home. While we're here, we'll also check the other ones. Y home is right and Z home is right. So we know that they've been set up correctly. Next we go back to our settings. Now depending on which direction the homing switch is going to go, we use this direction positive or negative. So we'll have a direction positive to start with, and we can press home X, and we can see it's going the wrong way for where it's going the right way for where our home switch is. And home correctly. Beautiful. So we'll run that back. We'll then go to our y-axis. Same thing, we'll check our wiring diagram to make sure our step and direction pins are right and we're using the right ports. We've already checked our home pin is correct. So we want to activate the Y home. It's going in the right direction. You'll notice that it went it's activated and then gone past the limit switch. In this particular case, we want to be able to get the maximum travel out of the machine. So we have it set, and that's where this 20 millimeters here comes in. It'll activate and then move forward 20 millimeters, and then zero the axis. We can do the same with our Z. So we go Z home. You can't see it on the screen, but that's run out to home and stopped. So we know our axis is all okay, and they're all three of them homed. Next stage is going to be to actually calibrate each axis to the right steps per unit. Now we're going to calibrate our x-axis. So we're going to use our probe to do this. So I've put a digital scale on the bed, held down with some magnets. I've put it in place and I've set it to 0. So we're going to get a probe. We're going to do a simple probe in the X direction, and we're going to 0 the offset when it does it. So we'll start our probe. The probe's done. Next we're going to move our scale as far as we can physically go. As the further distance we use, the more accurate the measurement will be. So initially we'll move the probe out of the way. Alright, I've moved my scale so it reads exactly 360.00 millimeters. So we write that figure down. Then we're going to use the probe again, but we're not going to zero it. So we're going to use that to check the measurement it thinks the CNC has moved. So we'll start that probe. So it thinks it moved 287.995 millimeters. So we've got those two figures. We'll now move our setup out of the way. We'll command back to X0. Then we'll go into our settings for X-axis and we'll use the calibrate, but we're going to actually use it backwards to what it normally is used for. So we know we want to move it 287.995 at a feed rate of 1000. And we know that's actually going to move at exactly 360 mil. So we'll go OK. And we know that is, from our measurement, that is 360 millimeters, 0.000. And that changes our steps to 159.9972. We then repeat that again, check to verify that it is correct. And in fact this machine is actually 160.00 because I've done this calibration before, and you'll find that it should be, technically that should be the same for all three axes because they all use the same ball screw and the same drivers. To verify that, I'll then use the same method on each of the axes to check that and make sure it's all fine. Now that we've got our steps per unit right, we can go up here to our velocity. Initially, while we're running this machine in, we'll set that at 3000 millimeters per minute as max velocity. Once the operator is used to the machine, that can be turned up to about 6000 millimeters per minute safely. But on a dovetail machine, you don't need to go that fast. It's only a short bed. The next thing to set up is our soft limits. So we'll go back to our X-axis again. We will home the X-axis. Right, now that it's homed, we can set our soft limits. Now these units are in machine coordinates. I just noticed that there's an offset here on the right offset of homing. That should be 0. And our homing speed is correct at 500. A down speed of 250, that's the back off. We want to set the machine coordinates to 0, and we don't want it to back off any homing units. Then we can jog the machine to the far extent of its travel. And we can have a look at this machine coordinates 375. So we'll put 375 as the maximum it can go, 0 is the minimum it can go, and we'll save that. When we enable soft limits here, no matter what you do, you won't be able to drive the machine outside those positions. We then repeat for the other axes, so we'll do Y next. I'll just turn soft limits off to start with. So Y, we want to home Y as well. And looking at the machine, we wanted our homing back off units to be 40 because we wanted to come a bit further forward. So we'll rehome that again. It'll go back, find the trigger, and then it'll come forward 40 millimeters. Just do that once again, so it doesn't appear to do it. And that's better. So it's set the Y machine coordinates to 0. We then go to the full extent of its travel. That's about as far as we want to go. So looking at that, with Y is minus 220. So we'll go minus 220 and 0. Next we'll do the Z as well. So Z will go up and home. So Z is 0, and then we'll drive it down to as low as we want the machine to go. And we're most likely never going to need to go lower than that, so minus 260. Save and apply. Then we go into your general setup, enable the soft limits, we'll save that. Now if we try and drive the machine outside those limits, it won't actually let us. So let's test that. We'll try and go down further. Machine stopped, it says we've reached the limits, will not let us go any further, so we've got to acknowledge that. You can go up out of the way. Check the Y. Same thing. Won't let us go too far. And X will be the same. So that protects our machine. No matter what we do, we can't crash the machine at any point. Now at this stage the X, Y and Z axes are calibrated, so we'll move on next after this to the probe.